Hello, this is Gareth Keane. This is the third video in the series looking at the solution of a typical traverse question, the question from the 2014 paper, a four-sided traverse. In the first video we looked at getting the horizontal distances from slope distances, and in the second video we looked at the angular misclosure and how to correct for it. So in this short video here, we're going to look at the form that we use for the traverse, which is this one here, and where we actually put our values from the first two steps. So if you remember the first step, we had to work out the horizontal distance from A to B, from B to C, from C to D, and from D to E. And if we come to the form here, this is the form that you're going to fill out and someone supplied to you in the exam. And where you need to do is you need to transfer the distance A to B into this cell here. So that's where the 112.635 comes from this cell here. A to B is 112.635, B to C is 106.264. So that goes into the second cell, B to C here. So it comes into that box there. Remember, this column is for the length, the horizontal distance M. Then this distance C to D, if we come back here, C to D is 164.605, and you can see that that comes into this cell here, C to D. And then D to A, if I come back here, is 180.310, and you can see that that comes into that cell there. D to A is 180.31. Then for the angular misclosure, first of all we have our initial value, which is the bearing from the line A to D, and that's given as 193 degrees, 10 minutes and 12 seconds. And then we have corrected for angular misclosure. We've corrected the angle here is 87, the angle at A is 87.0546. So I place that in here beside the symbol A, 87.0546. The corrected angle for B is 111.4812. That comes into this row here for angle B. Angle C, if we come back here, the corrected value is 97.4755. That comes into those three cells there. And for D, the corrected angle is 63.187. So that's after the -4 has been taken away from every angle. And that comes in here. So we have our distances, and we have the initial bearing of the first line, A to D. Then we have the corrected angle at each station. We have our corrected distances, and we have the initial point also here, the initial easting and northing for station A. Okay, so that's how we actually transfer the data into the form. In the next video, we're going to look at the whole circle bearings and how we work out the forward whole circle bearing A to B and the corresponding backward whole circle bearing from B back to A, and so on. We'll do for B to C, C to B, and so on. Okay, thank you for listening.